Hey everyone, it's Sergey again. In my latest video, I've discussed a Revit plugin that processes external XYZ points and, based on user configuration, creates model elements. One possible source of these points is an external device, and as a proof of concept I developed an Arduino-based distance measuring device for building and apartment modeling. I've outlined some minimal requirements for implementation, and today I want to share my progress, review its pros and cons, and explore ways to improve it moving forward. Let's review the device's construction. I've assembled it using standard sensors such as Ultrasonic Sensor for distance measurement, Gyroscope and Accelerometer for angle measurement, laser transmitter for laser pointing, and a button to capture the latest distance, rotation, and orientation values, calculate XYZ coordinates, and send them to the application. This is how the device looks like. We are calling it Mini Valley project. The core concept of this device is to calculate the XYZ coordinate of a point. When set to its zero position, the gyroscope calculates rotation around the z-axis, while the accelerometer detects changes in the y-axis angle. The ultrasonic sensor measures the distance to the point, and using mathematical formulas, the XYZ coordinates can be easily calculated. The device then sends these coordinates to a source file, which the Revit plugin listens to, creating objects in Revit in real time. My kid actually played a big role in building the device's case using Lego parts. They designed rotatable panels for the sensors, allowing movement along the Z and Y axis. This rotation helps to avoid obstacles and ensures precise targeting. Now, let's test it in a real scenario. I'm going to create a Revit model of the room I'm currently in. First, I need to launch the application and connect to the device. It's connected to COM3 port, so I'll select it and start designing. As I showed in my last video, we'll open Revit and run the plugin to listen for data from the source file. I'll begin selecting points one by one in a clockwise direction to generate the walls. I'm actually trying to pick points as close to the wall edges as possible, so that they automatically join in Revit. After that, let's place some family instances. For family creation, I'll set the category to furniture and select the flat panel TV family type. Then I simply pick a point on the wall to place it. I'll do the same for the bed family type, but with generic models category. The proof of concept in this case showed really good results and made the design process smooth and efficient. On the other hand, there is some drawbacks I'd like to highlight. Precision. Actually, this was the biggest challenge I encountered. While the ultrasonic sensor performs well and provides fast measurements at short distances, its accuracy significantly drops over the longer distances, making the readings unreliable. In my example, after finishing the scan of the current room, I needed to move to another one. However, this required adjusting device's reference point. By default, the reference point is set to 0, so to update it, I had to calculate an offset based on the reference walls. To do this, I'm picking points on existing walls, but when the measured distance exceeded something about 13 feet or more, the readings become inaccurate. As a result, the offset calculations were incorrect, leading to errors in the data. Additionally, there was some dust in the air, which also caused measurement issues. Some dust particles interfered with the ultrasonic signal, disrupting the sound transmission and leading to the corrupted readings. I've actually been thinking about a solution for this issue, and maybe finding a laser sensor that can accurately measure long distances is the way to go. Unlike ultrasonic sensor, laser-based sensors are less affected by dust and provide more precise readings over greater distances. The next issue is the case. Obviously, the current case design isn't sturdy enough, even though it was a lot of fun to build it with the kids. I need to come up with a better design and use a 3D printer to create a more durable and reliable housing. Additionally, it would be great to design a base for a tripod to enhance stability and mobility. And I suppose the last issue I've had is the wired connection. The current setup, which connects the laptop via cable, is really inconvenient to use. To improve the experience, switching to a Bluetooth sensor would offer better mobility and ease of use. Alternatively, I could switch to an ESP32 module, which has built-in Wi-Fi and Bluetooth, making it a more integrated solution. Overall, despite the challenges, working on this device has been a really interesting experience. It's allowed me to combine my creativity and technical skills, and involving my kids in the process made it even more fun. I think it's a pretty interesting concept with a real potential. It could be really useful on construction sites and interior design or even furniture design. Feel free to share your ideas. Where would you use it? I'd really love to hear it. Hope you enjoyed the video and see you soon. Later!